Hello viewers, in today's class we are going to take up some more initial value problems in differential equations, right? So here we have the first problem, and the equation is given as dy over dx minus y is equal to e raised to x, and the condition is y of 0 is equal to 1, right? So now here we see that the given equation is a linear differential equation of first order, right? And this equation is of the type dy over dx plus py is equal to q, right? So this equation is of this form, and here p and q are functions of x, right? So p and q are functions of x, and to solve this equation we have to first find the integrating factor. So the integrating factor for such type of linear differential equations is given by e raised to integral of p dx, right? And the solution of this equation is given by y multiplied by integrating factor is equal to integral of q times integrating factor dx plus c. C is the constant of integration, right? So here this equation is of this form. So let us first compare this equation with this one. So we can write this equation as dy over dx plus, here we can write minus 1 y and e raised to x. Clear? Okay. So now if we compare this equation with this one, we see that the value of p is minus 1 and the value of q is e raised to x, right? So here p and q are either functions of x or constants, right? Okay, so now let us find the integrating factor. So the integrating factor is e raised to integral of p dx. P is minus 1 and here we have dx, so this is e raised to minus integral of dx, and this is minus x, right? So the integrating factor of this differential equation is e raised to minus x. Now let us write the solution of this equation. So the solution is given by this expression. So we have y multiplied integrating factor is e raised to minus x, and then we have the integral value of q is e raised to x. Then we have the integrating factor as e raised to minus x dx plus c, right? So now we can simplify it. So here we have y times e raised to minus x, and here e raised to x and e raised to minus x get cancelled, so we are left with only dx here plus c, and this is y times e raised to minus x is equal to x plus c, right? So this is the general solution of this differential equation, and let us now apply this condition to evaluate the value of this constant of integration, which is c, right? So we are given the condition y of 0 is equal to 1, so it means when x is 0 we have y is 1. So substituting these two values over here, we get 1 times e raised to minus 0 is equal to 0 plus c, and e raised to 0 is 1, and we have 1 times 1 is equal to 0 plus c is c, so we have c is equal to 1, right? So the value of c is 1. So let us substitute this value of c over here. So we have y times e raised to minus x is equal to x plus 1, right? So this is the solution of this differential equation given this condition, right? Now we can also write this solution as y is equal to x plus 1 over e raised to minus x, and taking this e raised to minus x to the numerator, we can write it as x plus 1 times e raised to x. So the solution can also be represented like this. Now let us take one more problem. So here we have this differential equation dy over dx plus y over x equal to cos x plus sin x over x, and the condition is given as y of pi is equal to 1, right? So let us solve this problem. So here again let us rewrite this equation in this form, because this equation is a linear differential equation of first order of this type. So let us write this equation as dy over dx plus 1 over x. Here we have y, and here we have cos x plus sin x over x, right? Okay. So now this equation assumes this form. So this is p, and this whole function is q, right? So that this equation takes the form dy over dx plus py is equal to q, right? Okay. So now let us first find the integrating factor here. So the integrating factor is e raised to p dx, and the value of p is 1 over x and dx, right? The integral of 1 over x is log of x, and e raised to log of x is equal to x, right? So here we have used the result that e raised to log of f is equal to f, right? Okay. So once we have obtained the value of integrating factor, we can write the solution of this differential equation as y times integrating factor, which is x, and integral of q. Q is here cos x plus sin x over x multiplied integrating factor, which is x, right? And c is the constant of integration. So now we can write this expression as xy is equal to integral of multiplying these two terms by x. Here we have x cos x, here we have sin x, and dx plus c, right? Now here the integral of sin x is minus cosine of x, so we can write this expression as x cos x dx plus integral of sin x dx plus c, so we can write it as xy. And here we see that we have the product of two functions. So here we have the product of two functions, that is x and cos x, right? And to evaluate this integral, we'll use the method of parts, right? And we'll take this as the first function and this as the second function, right? So let us write the formula for integration by parts. The formula is uv dx is equal to u integral of v, then we have minus integral of the derivative of u, and then we have integral of v dx, and here we have dx, right? Okay, so now let us apply this rule over here. So we have first function x, then integral of cos x dx minus integral of the derivative of x is 1, and integral of cos x dx, and here we have dx, right? And the integral of sin x is minus cos x, and here we have c, right? Okay, now xy is equal to the integral of cos x is sin x, so we have x sin x, and here we have integral of cos x, so integral of cos x is sin x, right? And dx minus cos x plus c, and we have xy is equal to x sin x, and integral of sin x is minus cos x, so minus and minus get plus, so we have plus cos x minus cos x here, and plus c, right? And cos x get cancelled, so we have xy is equal to x sin x plus c. So this is the general solution of this differential equation. Now in order to find out the value of this constant, we'll make use of this condition. So we are given y of pi is equal to 1. It means when x is pi, the value of y is 1. So let us substitute these values over here. So we have pi times y, y is 1, and here we have x is pi, then we have sine pi plus c, and this is pi, and the value of sine pi is 0 plus c, and pi is equal to 0 plus c, so c is equal to pi. So the value of the constant of integration is pi. So substituting this value over here, we get the solution as xy is equal to x sine x plus pi, right? Now if we want to express this result in the form of y is equal to f of x, then we can take this x to the denominator here. So we can write y is equal to x sine x plus pi over x, and y can be written as taking x to the denominator of x sine x. So here x and x get cancelled, so we have sine x, and here we'll have pi over x, right? So this is the solution of this differential equation given this condition, and this solution is expressed in the form of y is equal to f of x.